Welcome to a course on MCP, the Model Context Protocol. And this is a quick crash course where we will cover our agenda will be what is MCP, MCP as a restaurant analogy. We look at why MCP matters. We look at a hands-on exercise where we will build a simple MCP based LLM interaction. Next, we're going to do MCP integration with Ollama. And then we'll look at how to build a web UI for MCP plus Ollama. So let's get started. First, what is MCP? Now, Model Context Protocol or MCP is a lightweight structured protocol used primarily for passing contextual information between large language models, which are LLMs, and applications or tools. It provides a structured way to instruct models, include metadata, manage responses, and clearly define context aware interactions. The key components of MCP include the context blocks. These are sections where instructions, examples, and context specific data are provided. Next, we have the structured messages. These are clear tagging and syntax which help models interpret the information consistently. And we have JSON like or YAML formatting. MCP typically leverages simple JSON or YAML style formatting for readability and ease of parsing. I'm not sure if this makes sense, so what I've done is I have a slide for MCP as a restaurant analogy. Now imagine you visit a restaurant and you're hungry. The process of placing your order, cooking the food, and serving your meal neatly resembles how MCP works. So let's break that down. So first, MCP request, which is your food order. You sit at a table and clearly tell the waiter your exact order. You say, I'd like a cheeseburger, medium rare, extra cheese, no onions, and fries on the side. In MCP, this is the structured request that includes what task you want, which is in this particular case a cheeseburger summarization. Next, we have specific details where I mentioned medium rare, extra cheese. These are the parameters like concise or short or temperature is zero point 0.7. Next, we have additional context, which is fries on the side, which is any extra input. So that takes care of our MCP request. Next, we have LLM or AI model, which I would like to call the chef. The waiter, which is your MCP request, delivers your detailed order to the chef. The chef, which is the AI or LLM model, example can be Ollama running Llama 2, carefully reads your instructions and then starts preparing the food exactly how you requested. So that's the role of LLM or the AI model. Next, we have the MCP response or your served meal. Once the chef finishes preparing your order, the waiter brings your meal back to your table. The meal arrives exactly as you specified, hopefully, and they'll say, here's your medium rare cheeseburger with extra cheese, no onions, and fries on the side. Now, similarly, MCP responses are neatly structured so that your application clearly understands and displays the model's output. Next, we have error handling or getting the wrong order. Sometimes things can go wrong. The chef adds onions by mistake. You complain to the waiter, who either fixes it immediately or explains the issue clearly. Sorry, we ran out of fries. In MCP, error handling ensures you always know exactly what's happening and why something might have failed. Now that brings us to the point why MCP matters, and I'm going to try to explain this in food terms. MCP ensures clear, structured, and error resistant communication between your request, which is the order, and the model, which is the chef. Now, without MCP, which is the structure, it's like yelling random food items towards the kitchen, which is chaotic and error prone. Using MCP is like having a professional waiter system ensuring the chef, which is the AI model, always understands exactly what you want and you always know what to expect on your plate, which is the response. So now enjoy your MCP meal. Next, let's jump into our hands-on exercise where we will build a simple MCP based LLM interaction. Now we're going to go through a step-by-step guide here. The scenario will be we will create a basic MCP request response interaction where we instruct a hypothetical LLM based application, which example can be an AI assistant, to summarize a provided article snippet. So our step one for this will be to define the MCP message structure. So what I'm going to do is I'm going to go to I have created a folder MCP which doesn't have anything in here. Create a new file. I'll just save it as in the MCP folder as, I'll call it test.py. I'm just going to name it Python even though I'm going to write some JSON here. So first we need to create a JSON style template which we'll be using. So I'm going to go ahead and start writing some example JSON here. So for that I'm going to say open bracket MCP version is 1.2. This is the version of the protocol that I'm using. Next, I'm going to say type is context request. This defines the type of MCP message. Example can be context request or context response. Next, I'm going to say request ID. I'll give some number 1, 2, 3, 4, 5. This is a unique identifier for matching request and responses. Next, I'm going to say task is summarization. The task definition for the LLM, that's what this is. Example can be here in this case is summarization, but can be translation or something else. Next, I'm going to say input is content equal to your article content here and close it. So this is the data or content provided for the task. Next, I'm going to say parameters is length is short, style is concise, and closes. These are the additional instructions or constraints. So that's my entire MCP JSON style template request right over here. Now, if I want to create a real example out of it, let's use an actual snippet from an article as an input. So I'm going to say MCP version is 1.0, type is context request, that's good. And here I'm going to say REQ request 001. I'll keep it summarization, and instead of this, I'll say generative AI technologies like GPT-4 have transformed multiple industries by enabling advanced text generation capabilities. Businesses are increasingly leveraging these technologies to automate customer interaction, content, and so on. So that's my content right here. Next, for parameters, I'll say length, keep it short, and style, keep it concise in this particular case. So this is how a real example looks like of MCP request. So that's kind of our step 2, which was to create a real example. Next, let's go to step 3, where we will be creating a hypothetical LLM response or in MCP format. So let's go ahead, and here I'm going to just comment this out, and I'll say this is my request. Next, for the response, let's see how does the response look like. For response, I'll say open bracket MCP version 1.0, type is context response because this is a response. Request ID is REQ001 matching to the request. And next, I'll say status equal to success. Output is summary, and I have some summary here based on the text that is here. Again, the only thing that is different here, status, which indicates success or failure of the task, and output contains the generated summary for this particular content that is provided. So this is a hypothetical LLM response that will be coming back for this request. So I am going to go ahead and make sure this is closed, and I'll comment this out. So that brings us to our next step. Step 4 is implementation. We'll do a Python example here, and here what we'll do is we'll write a simple Python script demonstrating how you might implement MCP communication with a mock LLM function. We'll be doing in the next step actual LLM, but for now just look at a mock LLM function. So I'm going to go back here, and I'll keep this here, and it will be available in the resources provided in the description. So I'm going to go ahead and start with import JSON because I need to convert stuff into JSON. Then I'm going to create my mock LLM summarizer, which takes the content, the length, and the style here. And I'm just going to create a placeholder for real LLM summarization logic. Next, I'll say return. generative AI, which was the response here. I've just taken that and kept it here. So that's my mock LLM summarizer. So this is how it will look like. Now let's go ahead and create an MCP request example. For that, I'm going to say MCP request equal to, I'll just take the same items here, MCP version, type, request ID, task, input is content, and then parameters are length and style, and I'll close that. So that's my MCP request. This is how you would do in Python. Next, let's go ahead and process the MCP request that we have. I'm going to say content equal to MCP request input and then content from there. Take the content out of that. I'll say length equal to MCP request, take the parameters and inside that length, and style is MCP request parameters and style. Why did I take these three parameters? If you remember, my mock LLM summarizer takes these three parameters. So I'm going to say summary equal to mock LLM summarizer, say content, length and style. I'll pass three parameters over there, and then I'll generate the MCP response structure. I'll say MCP response, again it's similar to this except for the summary will be the summary that I get here. Type request ID equal to, I'll get the same MCP request ID just to match this. Status equal to success because it's successful. Summary is summary because that's the data that I get here, and then I'll close it here. So that's what my MCP response looks like. Now let's go ahead and print this out. I'm going to say print json.dumps MCP response indent equal to 2. So what this will do is this will take my, that's why I'm importing JSON here. It will take my response here, MCP response, and print that out with indentation of 2. I can save this and go back here. I am in my terminal or command prompt and I'm in the MCP folder here. So I'm going to say Python test.py, and if you see, I get the response back based on this. Again, this is the mock style, but this is the actual process that happens. You make a request, you send it to your LLM, and in this case it's the summarizer, so it's going to summarize and give you back the MCP response, and that's what you take. So this is the actual standard. So in this particular case, we have our order here, which is our cheeseburger with onion, no onions, and whatever we specified with fries, and then that is sent by the waiter. So this is the waiter giving it to the chef. So the chef takes it. This is the chef who's our LLM summarizer in this particular case. You can have, again, the idea of MCP is to have multiple chefs. So that way we have multiple LLMs working for you. And then chef takes this order and then creates something and then gives you back your response, which is your meal, and you can and presented to you on your table. So there you go. We have our entire MCP flow right over here. So you kind of have a quick practical understanding of MCP, which is the Model Context Protocol, and a simple working example of how to structure and handle MCP requests and responses in practice. Our next step is to look at MCP integration with Ollama. The reason I'm using Ollama here is because Ollama makes running open source LLMs locally easy and fast. If you have not seen my videos on Ollama, I would recommend you go see those first before you look into it, or we're going to run a quick demonstration here. So we'll demonstrate how you can use MCP style messaging to interact with a locally hosted LLM using Ollama. So you can have that LLM running on your machine. Now let's go ahead and integrate the step by step where we will be integrating MCP with Ollama. So the prerequisites here, make sure that you have Python installed. If you don't have Python, go to Python's website and get it installed. And then next is Ollama. So I would say if you don't have Python, go to python.org and download it from there. And if you don't have Ollama, just go to ollama.com and download Ollama from right here. So you have both the elements available that we need. Once you have this, download Ollama, you run it and make sure that it's running. You can check if it's running by just saying Ollama here, and it will give you a bunch of different options. You can look at what all different models you have available. I have a bunch of different models downloaded here, but if you want to download them, you can look at models here, and it will tell you how you can just say Ollama pull the name of the model, and that will download it for you. So I have something running right now, so I'm not going to go through these steps. The steps that I'm going to follow is first install Ollama and run an LLM locally. So for that, I already installed Ollama, as I mentioned, as I showed you here. Next step is to run a particular model. So if you want to test a particular model, you can just say Ollama run llama 2. So what I'm doing is I am running this Llama 2 model that is available here, this one. It's about 3.8 GB. If I run this, it's going to go ahead and start giving me prompts. So it will ask me quickly, there you go, it will say send a message. I'll say what is 2 plus 2. Again, this is completely running locally and you don't even need internet for this. It will give you answers based on this. I'll say give me or just say what does model context protocol mean, and it's going to give you some explanation based on that. So this make sure that Ollama is running and you have some models available to play around with. Our step 2 in this particular case is to install the Python dependencies. Now we will need Ollama and request, which are used to interact with Ollama, and request are used to make the REST calls. So for that, I'm going to go here, and here I'll say, I think it's by is what I'm going to say, and it will close that. I'll clear it out, and I'll say pip install Ollama and request. So I need these two things. I think I already have them installed. That's why it says requirement already satisfied. But if you don't, it will install it for you. So perfect. So that's the next step. Our next step is to define MCP request response format. So we'll use the standardized JSON MCP request format that we have seen earlier. And I can create a standardized request here. I'm going to show you an example again. Go here, open this, and I'll save this file. This time I'll save it as I'll just call it request.json and start creating my request here. I'll open my bracket. I'll say MCP version 1.0. Type is, this is context request. Request ID is req-001. Task is text generation in this particular case. So I say text underscore generation. Input is prompt. Tell me about artificial intelligence in a concise way. So think of it as writing this and asking Llama 2 directly. Next, I'm going to close this. Parameters that I want is max tokens is 100, temperature is 0.7. So that's what I've specified, and that's all I need to specify for my request here. Now, if I want a response, the response will look something like this, where we have open bracket, MCP version is 1.0, type is context response, request ID should match this request, so it is 001, status is success, and output, depending on what Llama 2 will reply back, it will have some generated text displayed over here. So that's how my response for MCP will look like. So I'll leave this here and go to our step number 4. Now step number 4 is Python integration with Ollama. So the Ollama server is already running. We tested that out. So now let's go ahead and create a Python file. I'm going to go here and create a new file. I'll save this. In this particular case, I'll call it mcp underscore ollama.py. Now here, I'll start with importing first. I need JSON. Next, I'll say import Ollama. So JSON is used to convert to a string to JSON, and Ollama is to connect to the Ollama server that is running. So I'll create my MCP request message here. I'll say MCP request. This is the same as what we've created here. So I'm going to just write that down. MCP version 1.0. Type is context request. Request ID is req-001. Task is text generation. Input, in this case, I'll give a prompt. I'll say tell me about artificial intelligence in a concise way. And then I'll pass the parameters, which has max tokens and temperature. So that's my entire request. Next, I'm going to go ahead and extract the MCP fields that I need. So I'm going to say prompt equal to MCP request input and prompt, max tokens equal to MCP request parameters and max tokens, temperature is MCP request parameters and temperature. Now let's go ahead and write the Ollama interaction. For that, I'll say response equal to ollama.generate. So this is what we have downloaded. So this imported here, and I say Ollama, it has a generate function which takes first parameter is model, which is the model that we want to test. If you remember, we were running Llama 2 and we know that we have that installed. If you don't have it installed, install it from Ollama's website by saying Ollama pull Llama 2. Next, I'm going to say prompt equal to prompt, options equal to, so number of predict, which is max tokens, which tells how many tokens that I need. Temperature is the temperature that we have passed. And I'll close this and close this. So this will generate my response from the Ollama server that we have running. So let's go ahead next, prepare the MCP response to display the route based on the response that we have. So I'm going to say MCP response equal to MCP version 1.2. It's similar to this one what we have here. Context response. Request ID should match this request ID, so I'm specifying that. Status is success. Output is generated text response, and this response that we get here has a key value pair. The key is response, is where the response from the Llama server is, Llama 2 server or Ollama is. Close that, and then finally, as usual, let's go ahead and serve the dish, or as I say, print JSON dumps MCP response indent equal to 2. So that's it. That's our entire application. This time we are not doing any mock server. We are actually using an LLM which is running in the background on my computer and sending it an MCP request and displaying an MCP response out. So let's go here. This time it's called Python MCP underscore Ollama.py. Run it. It's going to go ahead, call my Ollama server, use the Llama 2 model, and then depending on what response it gives back, it will print that right here. It says artificial intelligence because our question was right over here. Tell me about artificial intelligence in a concise way. And there you go. It says artificial intelligence refers to development of computer system that can perform tasks that typically require human intelligence and so on. So we have the response back right here. So this kind of covers our step number 5, which is running our MCP plus Ollama integration. You saw that working. Our next step, which is kind of optional, you can do it, or if you don't want to, you can skip it to the next one, is to adding error handling. Now you can enhance your code by adding error handling for robustness. So for that, what I'm going to do is I'm going to go here where I am getting the response, and here I'll add a try catch. I'll say try, because what if the server is not running? What if the server is down or the LLM is down? So I'm going to say try to call Llama 2 with this prompt with these options, and based on this data that we have this response. So I'm going to move this also a little inside try, and then if anything fails here, I'm going to say except, which is my exception, and I'll say exception as E, and inside here I will say MCP underscore response, which is this exact same thing, but in this particular case we had an error. So I'll say error for this particular response, for this particular ID I have an error, and then as my I'm not going to give output because there is no output. I'll say error underscore message. That's what I'll pass, and here I'll say str e, something like this, and that I will print that out to the user whoever called it. So now we are handling errors here. So this is the perfect case scenario or God mode, and this here we have, if there was an error connecting to the LLM, then it will give me this error out here. So go ahead and try out with different models that are available. Now again, as I mentioned, there are a bunch of different models that are available that you can play around with. You can try with DeepSeek, you can try with QWQ, Gemma 3, all these different models, and try how it works. So this is how you can actually create a standard format of communicating with different LLMs. So this looks pretty cool. We have our data and we have our code and data, everything available. It looks pretty good. But what we can do next is to build a web UI for MCP plus Ollama. So what we're going to do is, in this particular case, we'll use for our backend Python FastAPI. For the front end, we'll use HTML, CSS, and JavaScript, and we'll just keep it basic. And for LLM, we'll just use the Ollama running locally. So our step 1 here is to set up the project and dependencies. So we'll create a new folder for that. So for that, I'm going to go ahead and actually inside this folder itself, I'm going to create a new folder, and this folder I will call it MCP underscore Ollama underscore UI. Okay, that's what I'll call. That's where all the UI will sit down, and inside here I'm going to go ahead and also make sure that I have dependencies installed. So I'm going to say pip install FastAPI, that is used for writing backend in Python. Then we have UVCon, that is to run the server, and then Ollama, we already have that installed, and I'll use Python multipart to communicate with the backend part with the form data that we have. So that will install everything. If it's already installed, you'll say request requirement already satisfied. If you have not, it will install it for you. So let's go ahead and clear this out. Our next step, or step 2, is to create the backend, which is the FastAPI. So what I'm going to do is I am going to, inside this, create a new file. This one, I'll call this as main.py, Python file. And in here, I will start with first from FastAPI, import FastAPI and request, which is used for creating the FastAPI server. Next, I'm going to say from FastAPI.responses, import JSON response and file response. Again, JSON response is to get the JSON data, and file response is to actually handle the HTML and JavaScript files. Next, I'm going to say from FastAPI dot static files, import static file. This is for kind of fetching the static files, which are HTML files that we are going to create in a minute. Next, I'm going to say import Ollama. So first step here is to create the FastAPI application. For that, I'm going to say app equal to FastAPI. Next step is to serve the static HTML or JavaScript files or CSS files that you have. For that, I'm going to say serve static HTML JS files. I'll say app.mount /static, which means there is a folder that I'm going to create here, new folder, static, where I'll keep the HTML, JavaScript and CSS file. I'll say static files. I'll use this directory static, name equal to static. So it kind of makes it easier if you name everything static here. Next, I'm going to write my first endpoint, that if the user comes to the root URL, which I can say by saying app.get/, I'll say run this function, which is async def root, and I'll say return file response static index.html. So when the user comes to the root folder, I want to display that HTML file which is inside this. Now we don't have that file here. I can just create that quickly, and I'll say index.html, and that's what will be served right here. Next, I'm going to say API MCP request. Whenever someone makes a request for the API MCP, I'll run this function, handle MCP request, pass the request here as the parameter, data equal to await request JSON. So this will make sure that we wait for the JSON data that comes from this API request that was made. Next, I'm going to say prompt equal to data, input and prompt. So inside that data that we get, we have input and prompt. If you look at, I'm going to probably create that soon. So you'll see, like when I call this URL, I'll pass a data object which has input, and inside that I have the actual prompt that will be passed, which you've done earlier, to this prompt here, to a Ollama. So let's go ahead and say max tokens equal to data. I'll also have parameters max tokens, temperature are data, parameters temperature. This is much similar to what we did right over here, where we had prompt, max token and temperature fetched from here. So next, I'm going to try say response Ollama generate. I'm going to go ahead and use the Llama 2 model. Say prompt is the prompt that we got. Next, I'm say options, number of prediction for tokens is max tokens. Temperature is temperature that is passed. Close it, and I'll say return. This time I'm going to say JSON response, MCP version 1.2. If you remember our response style, this is how we do it. Type equal to context response. Request ID is depending on what the request ID was. Status is success. Output is this generated text response. Again, close this. Now again, if there's exception, if there's some problem with the LLM, we say return JSON response, MCP version, type, request ID, status, and this time it's error, and I'll pass the error message. I'll close this right over here. So we have our entire code available here for our FastAPI backend, where we have created a FastAPI backend, and we are making sure that we are serving the homepage URL, and we have created a post API here, which is API/MCP request right over here. So that kind of takes care of this. Next, I'm going to go ahead and go to my index.html file here and write my HTML that will be displayed as a UI right now. So I'm going to go ahead and say doc type HTML, start with specifying the HTML document, HTML language equal to English, start with head, meta tag character set equal to UTF-8 format is what is the text will be. Again, the head is something that you don't see it but has metadata about the web page. Meta name viewport, content equal to width equal to device width, initial scale is 1.2. This will make sure that your website looks good on all the different devices. title equal to MCP plus Ollama. This will be displayed on the top like this: Ollama search or welcome to Python. That's what the title is. And then I'll write some CSS styles here. Sometimes people like to write CSS inside another file, but I'll just keep it here because I'm just making a simple website. So body, font family Arial, sans serif, margin is 2 rem, background color is F5, F7. Next, I'm going to say container. I'll create a class of container which hold the entire website, and for that I'll say max width is 800 pixel, margin is auto. I'll create a text area where you can enter the prompt, and for that the style is width is 100%, height is 120 pixel. Next, I'll create a button which will be used to generate the text or call LLM. So padding 10 pixel, 20 pixel, font size is 1 rem, cursor is pointer. Next, for the result, where the result will be displayed, I'll say background is white, padding is 15 pixel, margin top is 1 rem, border radius is 8 pixel. Close the style, close the head, and now write our body. Create that container that I mentioned. Say ish to a header tag, MCP plus Ollama interaction. Create a text area, which is my prompt area. It's a placeholder. Enter your prompt here. Tell me about artificial intelligence briefly. I'm just added some text here so I don't have to write it. Button is on click send request. This will call that function send request, which we'll be writing in a minute, for generate response. Then I'll say class result. This is where the result will be displayed depending on what data we get from as an MCP response, and we'll read that and get it here. Close the div, open the script for JavaScript. This function that we said here, send request, is implemented right here. Say prompt equal to document.getElement by ID prompt. So I'm guessing getting whatever user entered inside here. In this case, we have hard coded this, but you can remove it and let user enter something. But we'll get that prompt from there, get the value. Next, I'm going to say request data. Now I have to create a request data based on MCP format, MCP protocol. So MCP version 1.0, context request. Request ID is request UI 001. Task is text generation. Input is prompt, whatever prompt I have. Parameters is 150 token. Temperature is 0.7. Close this, close this. Next, as a results div, document.getElement by ID results. So depending on this item that we have, I'm saying that I want to create a handle to that. So result div.inner HTML, I'll set is loading as soon as the user presses this button. This is called. So I'm going to say loading. Inside this, I'll say constant response. I'll probably move it here. Anyways, method equal to post. So this is the API that we wrote in the backend here. If you remember this API MCP request, that's what I'm calling here. I'll say method is post because if you remember, this is the post function. I'll say header says content type application JSON. Body is JSON.stringify this particular request data, convert the JSON into string and pass it to this particular, and that will take it and then call the Ollama server and get the response and give it back to me inside response. Now say constant data equal to await response.json. Then I'll check if data.status equal to success, if the data that we got back is success, because we can get success or error. So if it's success, I'll say results div.inner HTML. So this results div that we have here, which we are actually catching here, say inner HTML is data.output.generated text, because if you remember here data.output.generated text, and this is where the generated text is. So that's what I'm displaying inside the results div. I'll close it, else there's an error, and depending on what the error message that was passed from the backend server, I'll display that. I'll close this here, close this, close script, body, and HTML. So that's our entire HTML file that we have created right over here for our UI. Our next step is actually creating the front end UI, which we just did. Next step is to run the application. So let's go ahead and run the application. Now we have UVCon for passing this. So let me make sure that I am in the right folder. I am inside MCP folder. So I'm going to go inside MCP underscore Ollama underscore UI folder. Okay, let's clear this out. So that's the folder where all the code is. And here I'm going to say UVCon. So the way to run our server is you say UVCon, name of the file. What is the name of the file? The backend main.py. So I'm going to say main. That's what I'll say. Our next step is the name of the application. If you remember, the name of the application is app. So inside main, I'm running app, and I will also add this another key here, say reload, which means if there is some changes or something in this particular file while I'm testing it, I want the app to be reloaded. I don't want to run it all over again. So I'm going to press this enter, and now that is running. Now, next step is to open and test the web UI. So for that, since the server is running on this particular port, I'm going to copy this URL with port, and I will put it on my browser. Now I'm not going to press enter yet. When I press enter here, what it does, it goes to the root URL, which is this particular file here, this particular call here, and it will give me static index.html. So let's see if it does that. And there you go, we have our HTML file provided right here. It automatically added this text over here, so I'm just going to use that. You can again, you can change this to whatever you want, but it's up to you if you want to see something else. Then I'll press this button. When I press this button, what will happen right here? It will call send request, which will call the backend API MCP, this one, which in short will take that and call the Ollama service and then give me a response, and I'll take the response and display it back here. So let's go ahead and click on get response. Now if you see, loading is displayed. It's going back to the fast API. It is going to call the Ollama service and run the llama model 2 over there and ask it this question, and here is the answer that we get from llama 2. Again, if you see it's cut, the reason is because I've set the tokens in here to 150. That's why it has cut it short here, or else it will keep on giving you more data. And there you go. So we have our entire flow. We created our MCP server, we created our backend server. I made sure that we have an LLM that is available right now, and we saw end-to-end system from user front end to the backend of how it coordinates the MCP request, goes from the UI to the fast API to back to the Ollama service, and then calls the model and then gives it the prompt that we specified and gives back a response in MCP format, gives it back, and we are displaying it right here back in our web page provided to the user. So I hope you were able to follow along and get through this project. Let me know if you have any issues or problems in the comments, and I'll get back to you.